But even though it looks messy, if we really pick out a good U, I'm going to guess it's this stuff under the square. Then taking the derivative of both sides over here, the derivative of e to something is still e to something, but you need to do the chain rule. So derivative of negative x would be -1. And remember, the whole point of u substitution is to make things look nicer so that we can do them in our head. So it doesn't really matter how complicated this looks. If we're careful about this, I have already said this is u, this is like u squared in the denominator. Gotta make sure I put my fraction bar so I don't forget that it's in the denominator. This isn't a perfect match for this just yet, but if I multiplied this side by 2, that's fine as long as I multiply that side by 2. So now I can see in place of all of this stuff, which is what I have, I can replace it with 2 du. So picking out the u is not always easy for people to see, but again, it's almost always trapped under something. Taking the derivative of both sides should be okay for you. Adjusting this, multiplying it by 2 to make sure that it matches this, and then you just plug these things in, and now it should look much more manageable. I'm going to change this from u squared to u to the -2. I'm going to integrate by raising the power by 1 and then dividing by the new power. So -2 times u to the -1, and then all the way back up here, just plug that u back in, and then that should be fine. And again, I'll stop saying it to annoy you once I believe that you consider it. If you had time, check your answer by taking the derivative. So I guess you'd probably need to use the quotient rule, but still need to know the quotient rule, so that's not bad practice there.